In this video, we're going to learn how to factor out a binomial GCF. In the examples that we've done so far, we've only factored out a GCF that's a monomial. But is it possible for a GCF to be a binomial? Well, sure it is. Let's take a look at this example. Here we're asked to factor 6a times the sum x plus 2y minus 7 times the sum x plus 2y. Now, it's a little bit hard to tell in this, but we're asked to factor this expression, and this expression contains only two terms. The first term is the 6a times the x plus 2y, and the second term is minus 7 times x plus 2y. And if we want to factor out a GCF from both of these terms, it's easy to see that both of these terms have a factor of x plus 2y, because the first term is 6a times x plus 2y, and the second term is minus 7 times x plus 2y. So in this case, our GCF isn't a monomial, but it's a binomial. Now remember, once we've identified the GCF, when we factor a polynomial, we're always going to write that GCF out in front of our parentheses. But in the cases where we have a binomial GCF, we also have to put the binomial GCF in parentheses. And then, just like we did in our previous videos, we'll figure out what goes inside the second set of parentheses by dividing each term by the GCF. So let's start by dividing the first term in our expression, the 6a times x plus 2y, by x plus 2y. When we divide the first term by x plus 2y, the two factors of x plus 2y in the numerator and denominator are going to divide out, and so that leaves us with just 6a. And so 6a is the first term in our second set of parentheses. Now let's divide the second term, negative 7 times x plus 2y, by the GCF of x plus 2y. Again, we'll see in the numerator and denominator, the factors of x plus 2y cancel out and leave us with just negative 7. And so minus 7 is our second term in our set of parentheses. So there is the factorization of the expression that we were given. It's x plus 2y times 6a minus 7. Here again, we're asked to factor, and we're given an expression with two terms. The first term is 3 times the sum z plus 5, and the second term is minus 7x times the sum z plus 5. Remember, the best first step is to always look for a GCF. And remember, the greatest common factor doesn't always have to be a monomial. It can be a binomial. So do you see a binomial that each of these terms have in common? Yeah, it's z plus 5. So the greatest common factor here is not a monomial, it's a binomial, z plus 5. So we begin our factorization by taking our GCF, which in this case is a binomial, z plus 5, and writing it outside of our parentheses. Now we have to find what's left over when we divide the first and second term in this expression by z plus 5. Well, a little shortcut that we can use when we have a binomial GCF is that when I divide the first term by the binomial GCF, the only part of that term that's going to be left is everything but the z plus 5. So in other words, 3 is what's left when I divide 3 times z plus 5 by z plus 5. Same thing with the second term. The leftover part of the second term, when I divide it by z plus 5, will just be the minus 7x. So the factored form of this expression is the GCF of z plus 5 times the difference of 3 minus 7x.